Find the energy of A, a photon having a frequency of 5 times 10 to the 17 hertz, and B, a photon having a wavelength of 3 times 10 to the second nanometers. Express your answers in units of electron volts, noting that 1 electron volt is equal to 1.60 times 10 to the negative 19 joules. Now, we want to find what the energy is in both A and B of this problem. So we want to find that energy. But we know that in A, we're given the frequency, which is equal to 5 times 10 to the 17 hertz. And then in part B, we are given the wavelength lambda is equal to 300 nanometers. Okay, so now we want to find the energy. So for part A, we know from lecture that the energy is equal to H, which is Planck's constant, times the frequency. So we know that Planck's constant is equal to 6.63 times 10 to the negative 34 joules seconds. Okay, that is Planck's constant. But let's calculate that energy. So if we know Planck's constant is 6.63 times 10 to the negative 34 joules times seconds, and we know that the frequency is 5.00 times 10 to the 17 hertz, now we can find that energy. And that energy is equal to 3.32 times 10 to the negative 16 joules of energy, because remember that hertz is basically an inverse second. So the seconds cancel and you're left with joules. So now we want to convert this into electron volts, because that's what the problem asks. So we know that 1 eV is equal to 1.60 times 10 to the negative 19 joules. So we're going to take our 3.32 times 10 to the negative 16 joules times, we're going to set up a conversion chain. So 1 electron volt is equal to 1.60 times 10 to the negative 19 joules of energy. So joules cancel, and we're left with 2.07 times 10 to the third electron volts, or 2.07 kilo electron volts. That is our energy for part A. Now in part B, we're asked to find the energy again, but this time we need to know what, and I wrote this wrong, sorry. We need to know what the frequency is in this case, because we've been given the wavelength, but we don't know what that frequency is. The way we find the frequency is from this equation that we talked about last class, where the speed of light is equal to lambda f. Okay, so you may have seen that before. So that means that the frequency is equal to c over lambda. So what I'm going to do first is just solve for this frequency. So that's 3 times 10 to the 8th meters per second divided by lambda, which is 300 times 10 to the negative 9 meters. Okay, and so this will give me an energy E equal to, so this comes out to 1 times 10 to the 15 hertz. So now my energy, which is HF, is equal to 6.63 times 10 to the negative 34 joule seconds times 1 times 10 to the 15 hertz, which is inverse seconds. And so that energy E is going to equal to 6.63 times 10 to the negative 19 joules. Now remember, they want this in electron volts. So we got 6.63 times 10 to the negative 19 joules times 1 electron volt divided by 1.60 times 10 to the negative 19 joules. This equals to 4.14 electron volts. So that energy is 4.14 EVs.